Okay, so now let's look at numbers 7 to 9 on the front side of your forces sheet, okay, the forces review sheet. So number 7 says the acceleration of a 400 kilogram car is 0.55 meters per second squared. Frictional force is 80 newtons, and it wants you to calculate the force to get it moving and the mu. So I have all my forces drawn in. We need the y direction for the second part, so we may as well do it now. We'll start with it. So in the y, we have Fn going up and Fg going down, and that will be equal to 0. So Fn will be equal to Fg will be equal to mg. And so you could do 400 times 9.81. Just for fun, let's just leave it at that for now. And let's do part A, which wants the force that you need to push with, or the force that needs to be exerted on the car. So sum of the forces in the x direction. So there's F going forward and friction going backward, and that's equal to max, and you're just solving for F. So it'll be max plus friction. So M is 400 kilograms. A is 0.55 meters per second squared, and friction was 80 newtons. So plus 80 newtons. So F is equal to 400 times 0.55 plus 80. So you get a nice pretty number of 300 newtons, I hope. Yeah, that's even what I tell you. Okay, so that's part A. So then part B wants to know what's the coefficient of friction. So we know FFR is equal to mu Fn. So mu is equal to FFR over Fn. FFR, you were told, was 80 newtons, and Fn you found up here to be mg, and I just didn't bother to type it in then. So m is 400 kilograms, and g is 9.81 meters per second squared. So 80 divided by 400 times 9.81. So this is going to be 3924 newtons. And so you end up getting a mu of 0.020387. Okay, number 7. Number 8, you're pulling up at an angle, and the question wants the acceleration of the box. Okay, so you could go to cos theta will be equal to fx over f. So fx will be equal to f cos theta, which you could find if you want it. So 88 newtons times the cos of 36.87. Fx is equal to 70.4 newtons. And in the y, it'll be sine theta. So Fy will be F sine theta. So Fy is equal to 88 newtons sine of 36.87.6. So 88 times 0.6, 52.8 newtons. So you have your Fx and you have your Fy. So we go to some of the forces in the y direction. It's not moving in the y. So we have Fn going up, Fy going up, Fg going down. Fn then is equal to Fg minus Fy. Oh, and it tells us it is a 196.2 Newton box, so it tells us Fg. So Fn then is equal to 196.2 newtons minus 52.8 newtons. So we get our Fn. What is that? 143.4 newtons. Okay, So then we can go to our sum of our forces in the x direction equals max. So we have Fx minus friction is equal to max. Friction is really just mu Fn. So we could write this as Fx minus mu Fn. Rather than do it as a separate step, we're solving for A, so divide by m. So Ax will equal 70.4 newtons minus 0.244 times 143.4 newtons. And divide by 9.81, so your m is 20 kilograms. Ax equals, so times 0.244 plus 70.4. So on the top you get 35.4, I think, over 20 kilograms. So 1.77. 0.52 meters per second squared. And the second part of the question says, if it starts at rest, VI is 0, how far will it have moved in 6 seconds? Delta t is 6 seconds. You have your A, so delta d is equal to VI delta t 1/2 A delta t squared. This goes to 0. Delta d is equal to 1/2 1.77052 meters per second squared by 6 seconds squared. 36, half of 36 is 18 times your 1.77, 31.6869, 36 meters, and you are done. Okay? All right, and then number 9. Number 9, you're pushing on a box at an angle of 30 degrees, and it wants to know what's the coefficient. So again, your Fx will be F cos theta, which will be 200 newtons cos of 30. And your Fy, I hope it's okay that I skipped this step, but we're running out of video. And it's 200 newtons sine of 30, which is 100 newtons. And this is 173.2 newtons. So we go to the x to y direction, and you're pushing this time, so Fy will be down. So Fn minus Fy minus Fg equals 0. So Fn equals Fg plus Fy. And Fg is 30 times 9.81 meters per second squared. And you're going to do plus 100 there. So Fn equals 394.3 newtons. So then we go to the x direction, and we have Fx minus friction is equal to max. You're solving for friction, so switch these. So Fx minus max, and that's going to be equal to friction. But friction is really just mu Fn. So F cos theta minus max is equal to mu Fn. And you could divide by your Fn here and do it all in one step. So you'll have mu is equal to F cos theta, or Fx, so 173.2 newtons, minus m, which was lost at 30 kilograms, times 1.8 meters per second squared, and that's going to get divided by your Fn, which you found over here, to be 394.3 newtons. So mu equals, on the top, 173.2 minus 30 times 1.8. So on the top you get 119.2 newtons divided by that, and you get a mu of 0.3.